Hello, and welcome. I'm so glad you're here. Before we begin, I'd love it if you could share in the comments where you're listening from and what time it is for you right now. It's always a joy to see people tuning in from different corners of the world and at different moments in their day or night. I also want to take a gentle moment to thank those of you who have already subscribed to this channel and who keep pressing that little like button on the videos that you find most valuable. It truly helps me know what resonates with you, and it helps others find these calming spaces too. And if you ever have ideas or topics you'd like me to explore in future videos, please feel free to suggest them in the comments. Your thoughts and inspirations are always welcome here. So, with that said, let's begin. Chapter 1. Understanding Tectonic Plates. The Earth, a majestic sphere cradled in the cosmos, holds within its depths a dynamic and ever-evolving structure known as tectonic plates. These colossal slabs of rock, some stretching thousands of kilometers, form the rigid outer shell of our planet, known as the lithosphere. Picture the Earth like a gigantic jigsaw puzzle, with each tectonic plate forming a distinct piece, fitting together to create the intricate surface we stand upon. Beneath this solid crust lies the asthenosphere, a semi-fluid layer that allows these plates to glide and shift over time. The definition of tectonic plates extends beyond mere physicality. They encompass the forces and movements that shape our world. Each plate interacts with its neighbors through a series of boundaries, categorized into divergent, convergent, and transform types. At divergent boundaries, plates drift apart, giving rise to new crust as magma wells up from below. Imagine the slow, steady creation of new land beneath the ocean, a testament to the Earth's ability to renew itself. Conversely, at convergent boundaries, plates collide, leading to monumental geological events, such as mountain building or volcanic eruptions. Have you ever gazed upon a mountain range and marveled at its formation? It is the result of these immense tectonic forces at play, pushing the Earth upwards through time. Transform boundaries, meanwhile, allow plates to slide past one another, often resulting in earthquakes that remind us of nature's raw power. The history of plate tectonic theory is a captivating narrative of scientific discovery, one that unfolds over centuries. The concept began to take shape in the early 20th century, with Alfred Wegener introducing the idea of continental drift. His proposition, that continents were once a single landmass before drifting apart, sparked intrigue and skepticism alike. Imagine the audacity of suggesting that continents could move, as if they were mere figurines on a grand board. Though Wegener's ideas were initially dismissed, they laid the groundwork for future exploration. As the decades unfolded, the scientific community pieced together more evidence to support Wegener's vision. The advent of the mid-20th century brought revolutionary advancements, particularly in oceanography and geology. Researchers like Harry Hess and Robert Dietz contributed to the understanding of seafloor spreading, showing how new oceanic crust formed at mid-ocean ridges. This was akin to unveiling a hidden mechanism of the Earth, revealing how the very fabric of our planet was woven together through constant change. The theory of plate tectonics solidified in the 1960s, transforming into a unifying framework for understanding geological processes. As geologist John Tuzo Wilson aptly noted, plate tectonics is a unifying theory. It explains almost everything we see. The importance of tectonic plates in Earth's geology cannot be overstated. They are the catalysts for many of the planet's most dramatic features and events. Earthquakes, for instance, are a direct result of the interactions at plate boundaries. Visualize the Earth trembling beneath your feet, a reminder of the immense forces at work deep within the planet. Each quake tells a story, revealing the tension that builds as plates move and shift. The rich tapestry of our geological history is written in these seismic occurrences. Volcanic activity, too, is intricately tied to tectonic plates. When plates subduct, or one plate is forced below another, it creates a pathway for magma to escape, forming volcanoes. The fiery eruptions that spew molten rock and ash are nature's dramatic expressions of the Earth's inner workings. Imagine standing before a volcano, feeling the heat radiate, and witnessing the raw power of creation and destruction in one breathtaking moment. Beyond the spectacular, tectonic plates also play a crucial role in shaping ecosystems and influencing climate. The movement of plates alters geographical features, creating mountains that affect wind and rainfall patterns. As the landscape changes, so too do the habitats for countless species, guiding the course of evolution itself. It is an intricate dance of life, one that has been unfolding for millions of years, shaped by the relentless movement of these plates. As we ponder the significance of tectonic plates, we might ask ourselves, what would our world be like without them? The answer lies in the very foundation of our understanding of geology, as well as the myriad life forms that inhabit our planet. The beauty of mountains, the vastness of oceans, and the fertile valleys all owe their existence to the slow, deliberate movements of the plates beneath our feet. In the grand scheme of Earth's history, tectonic plates are not merely passive components. They are active players in the drama of geological evolution. Their movements have sculpted the surface, shaped climates, and influenced the distribution of life. The very land we tread upon is a reflection of the ceaseless activity of these massive structures. As we explore the realm of tectonic plates, we uncover a world of interconnections, where geology, biology, and even human culture intersect. The ancient civilizations that flourished along tectonic boundaries learned to adapt to the rhythms of the Earth, finding beauty and challenge in the landscapes shaped by these mighty forces. From the Andes to the Himalayas, the stories of humanity are woven into the fabric of the Earth's geology, a testament to our resilience in the face of nature's power. So, as we embark on this journey of understanding tectonic plates, let us remain aware of the delicate balance that exists within our planet. The forces at play are both breathtaking and humbling, reminding us of the transient nature of our existence in the grand tapestry of time. The Earth continues to evolve, each moment a whisper of the past and a promise for the future. In the end, we are but witnesses to this magnificent process, standing on the shoulders of giants, both geological and human. As we further immerse ourselves in the world of tectonic plates, we begin to appreciate the intricate processes that govern their movements and interactions. It is fascinating to consider that the very essence of our planet's surface is in a constant state of flux, shaped by forces that are both ancient and ongoing. The mechanisms driving these colossal plates are rooted deep within the Earth, where heat from the core creates convection currents in the mantle. These currents, like slow rivers of molten rock, act as the engine behind the movement of tectonic plates, pushing and pulling them in various directions. Imagine for a moment the vastness of the mantle, lying beneath the lithosphere. It is not a solid mass, but a dynamic layer, capable of flowing over geological time. The heat produced by the decay of radioactive elements, alongside residual heat from the planet's formation, generates an environment where these convection currents thrive. This intricate interplay of heat and movement is a silent orchestra, conducting the symphony of geological activity that shapes our world. Throughout history, the interplay of tectonic forces has sparked some of humanity's most profound scientific inquiries. The stories of pioneers in geology, like Marie Tharp, stand out as testaments to human curiosity and determination. Tharp, a cartographer, was instrumental in mapping the ocean floor and providing evidence of seafloor spreading. Her work laid a foundation for understanding how tectonic plates could drift apart, revealing a hidden world beneath the waves. Reflecting on her contributions, she once said, "I think the most important thing is to not be afraid to try new things." Her pursuit of knowledge pushed the boundaries of our understanding and illuminated the pathways of the ocean's depths. As we contemplate the significance of tectonic plates, we must also consider how their movements have influenced the formation of natural resources. The collision and separation of plates have given rise to not only mountains and valleys, but also mineral deposits and fossil fuels. These natural resources are the legacy of geological processes that have unfolded over millions of years, illustrating the interconnectedness of Earth's systems. What if we pondered the implications of these resources on our daily lives? The minerals extracted from the Earth's crust have become integral to modern society, fueling industries and technologies that shape our existence. From the copper that wires our homes to the coal that powers our cities, the products of tectonic processes are woven into the very fabric of contemporary life. Yet, with such power comes responsibility. The extraction of these resources often leads to environmental challenges, including habitat destruction and pollution. The delicate balance between harnessing the Earth's bounty and preserving its ecosystems is a dilemma that requires thoughtful consideration. As we navigate this path, it becomes essential to reflect on our role as stewards of the planet, recognizing that our actions can ripple through time and affect future generations. In addition to their economic significance, tectonic plates also hold profound implications for global climate patterns. The rise of mountain ranges can alter wind and weather systems, creating regions of abundant rainfall or desolate deserts. Picture the towering peaks of the Rockies or the Himalayas, their majestic forms influencing the very air we breathe. The interaction between tectonic activity and climate is a reminder of how interconnected our planet is, where changes in one domain can resonate throughout others. One might wonder how these geological processes have shaped the course of life itself. The evolution of species is often tied to the shifting landscapes created by tectonic forces. As continents drift and collide, environments transform, presenting new challenges and opportunities for life. The story of evolution is a testament to resilience and adaptability, where species must navigate the ever-changing terrain of their habitats. Consider the flight of birds, which often travel vast distances across continents, their journeys intricately linked to the geography shaped by tectonic plates. Each migration is a reflection of the interconnectedness of life, where the movements of the Earth beneath them dictate the availability of food, breeding grounds, and the very climate they inhabit. As we explore these themes, we may find ourselves contemplating the future of our planet. The forces that govern tectonic plates continue to operate, and while we may not perceive their effects on a daily basis, they remain a powerful presence. Earthquakes, volcanic eruptions, and the slow rise of mountains are all reminders of the dynamic nature of our world. What lies ahead in the geological timeline? Will new mountain ranges rise, or will existing ones erode away? The answers to these questions are shrouded in the mysteries of time, yet they invite us to ponder the resilience of our planet and the stories it has yet to tell. In the grand narrative of Earth's history, tectonic plates are the protagonists, constantly shaping the stage upon which life unfolds. Their movements echo through time, reminding us that change is an inherent aspect of existence. As we stand on the surface of this dynamic planet, we are reminded of the forces at work beneath our feet, shaping not just our physical environment, but also our understanding of life, resilience, and the interconnectedness of all things. With each thought, we deepen our appreciation for the Earth and its geological wonders. The journey of understanding tectonic plates is not merely an exploration of science. It is a journey into the heart of our planet's story, one that speaks of both creation and transformation. Each layer of rock tells a tale, a testament to the forces that have shaped our world and continue to do so, inviting us to remain curious about the mysteries that lie ahead. Chapter 2. Types of tectonic plates. Imagine standing on the edge of a vast ocean, the waves lapping gently at your feet, while beneath the surface, a world of immense geological forces is at play. This hidden realm is shaped by the movement of tectonic plates, each with its own unique characteristics and roles. Let us explore the major tectonic plates that cloak our planet, their locations, and the subtle nuances that differentiate them. Take a moment to picture the Pacific Plate, the largest of all tectonic plates, stretching across the Pacific Ocean from the shores of California to the coasts of Japan and New Zealand. It is a behemoth, covering an area that rivals entire continents. The North American Plate, situated to the north of the Pacific Plate, includes not only the landmass of North America, but also parts of the Atlantic Ocean floor. To the east, the Eurasian Plate spans a vast area, encompassing Europe and much of Asia. Traveling southward, the African Plate cradles the continent of Africa, while the South American Plate cradles South America, extending westward into the Atlantic Ocean. In the southern reaches of our globe, the Antarctic Plate lies beneath the icy expanse of Antarctica. It is flanked by the smaller Nazca Plate to the west, which is a crucial player in the tectonic drama unfolding along the Pacific coast of South America. Each of these plates is part of a grand mosaic, contributing to the dynamic nature of our Earth. But what exactly sets oceanic plates apart from their continental counterparts? Oceanic plates, like the Pacific plates, are generally thinner and denser than continental plates. Imagine them as the foundation of the ocean, composed primarily of basalt, a dark volcanic rock. This composition gives them a unique character, allowing them to sink beneath the lighter continental plates during subduction, where one plate dives beneath another. This process can lead to the formation of deep ocean trenches, such as the Mariana Trench, the deepest part of the world's oceans. On the other hand, continental plates are thicker and less dense, primarily composed of granite, a lighter rock that contributes to their buoyancy. They rise higher above sea level, forming the land masses we inhabit. When these plates collide, the result can be incredible. Picture the Himalayas towering above the landscape, formed by the collision of the Indian Plate with the Eurasian Plate. The immense forces at work not only create mountains, but also cause earthquakes that can shake the ground beneath our feet. As we delve deeper into the world of tectonic plates, we encounter smaller plates and microplates that play an equally significant role in shaping our planet. These smaller entities, though not as massive as their larger counterparts, are essential players in the geological game. For instance, the Juan de Fuca Plate, located off the coast of the Pacific Northwest, is a microplate that is subducting beneath the North American Plate, giving rise to the volcanic activity of the Cascade Range. Consider the Caribbean Plate, a small but vital plate that lies beneath the Caribbean Sea and parts of Central America. This plate is crisscrossed by complex boundaries, where its interactions with neighboring plates generate both earthquakes and volcanic activity. The tectonic dance around the Caribbean Plate has shaped the landscape of islands such as Puerto Rico and Cuba, showcasing the power of these smaller plates. Microplates are often hidden in the shadows of their larger siblings, yet they can hold a wealth of geological history. The Gorda Plate, located off the northern coast of California, is another example of a microplate that contributes to the dynamic nature of the region. Its interactions with the Pacific Plate and the North American Plate create a fascinating interplay of forces. Why do we study these smaller plates? They offer insights into the history of our planet. Each plate, regardless of size, carries with it a record of the Earth's past, etched in rock formations and geological structures. By understanding their movements and interactions, we gain a clearer picture of the processes that have shaped our world over millions of years. As we reflect on these diverse types of tectonic plates, we might wonder how they influence the life that thrives on our planet. The answer lies in their constant movement and transformation. The shifting of plates can lead to the creation of new ecosystems, the alteration of landscapes, and even the emergence of new species. Imagine how the uplift of mountains can create distinct climates, where one side is lush and green while the other is arid and dry. In the words of geologist John McPhee, the Earth is a dynamic system, and everything is changing all the time. This constant change is not merely an abstract concept. It is the very essence of life on Earth. The tectonic plates, with their intricate relationships and diverse characteristics, are the architects of our planet's landscapes. As we consider the vast oceanic plates and the sturdy continental plates, the smaller plates remind us of the intricate balance of forces at play. Imagine a delicate scale, where each plate contributes its weight, influencing the equilibrium of the Earth's surface. This balance is crucial for maintaining the conditions that allow life to flourish. The study of tectonic plates is not just an academic pursuit. It is a journey into the heart of our planet. Each plate tells a story, a narrative of transformation and resilience. The interactions between these plates shape not only the physical world around us, but also the very essence of our existence. So, as we continue to explore the wonders of tectonic plates, let us appreciate the complexity and beauty of this dynamic system. The Earth is alive, its surface constantly molded by these colossal forces. What stories will the plates tell us next? What secrets lie beneath the surface, waiting to be uncovered? The answers await us in the depths of our planet, where the dance of tectonic plates continues, ever shaping the world we call home. Picture the intricate web of tectonic activity that unfolds beneath the surface, where the movements of not only major plates but also the smaller and lesser-known plates contribute to the Earth's ever-evolving narrative. These smaller plates, often overshadowed by their larger counterparts, possess unique characteristics and play a pivotal role in the grand scheme of geological processes. Consider the Cocos Plate, which lies off the west coast of Central America. It is a small yet significant player, subducting beneath the North American plate and giving rise to the volcanic activity along the Central American volcanic arc. Imagine the fiery eruptions that result from this interaction, shaping the land and creating rich soils that nurture diverse ecosystems. The dance of the Cocos Plate exemplifies how even smaller plates can have an outsized impact on the environment. As we reflect on these smaller plates, we encounter the concept of microplates, which are even more diminutive but no less important. One such example is the Aegean Sea Plate, a microplate situated in the eastern Mediterranean. This plate is caught between the larger Eurasian and African plates, resulting in a complex geological setting that has contributed to the rich history of the region. Imagine the ancient civilizations that flourished on the shores of this microplate, influenced by the tectonic forces that shaped their landscapes. The interactions among smaller plates and microplates often lead to fascinating geological phenomena. The Philippine Sea Plate, for instance, is surrounded by several other plates, each exerting its influence. This complex arrangement creates a zone of intense seismic activity, giving rise to earthquakes and tsunamis. Have you ever pondered how these natural events, while often destructive, also lead to the creation of new landforms, such as islands and ridges? Nature's cycle of destruction and creation is a powerful reminder of its resilience. As we delve deeper into the characteristics of these smaller plates, we find that their boundaries can be just as varied and dynamic as those of larger plates. Take, for example, the boundary of the Juan de Fuca Plate, which is characterized by both subduction and transform movements. This duality creates a landscape where divergent and convergent processes coexist, resulting in a unique geological tapestry. The complexities of these smaller plate boundaries illustrate that the Earth is not a static entity. It is a living, breathing system, constantly in flux. Examining the smaller plates also brings us to the fascinating world of tectonic hotspots. These are areas where plumes of molten rock rise from deep within the mantle, creating volcanic islands that can form far from plate boundaries. The Hawaiian Islands are a prime example, resulting from the activity of the Pacific Plate moving over a stationary hotspot. Imagine the molten rock beneath the ocean floor, pushing upwards to create lush islands surrounded by the vastness of the Pacific. The juxtaposition of fire and water is a stunning reminder of the power of the Earth's inner workings. In contemplating the movements of these smaller plates, we might ask ourselves how they affect the larger geological landscape. The answer lies in their ability to influence tectonic activity in surrounding regions. For instance, the interaction of the Caribbean Plate with the North American and South American plates generates significant seismic activity, impacting not only the geology of the Caribbean, but also the broader Atlantic region. This interconnectedness highlights that no plate exists in isolation. Rather, they are part of a vast, intricate network that shapes our planet. Furthermore, the study of smaller plates and microplates offers a glimpse into the geological history of our Earth. Each plate carries its own narrative, etched in the rocks and formations that tell tales of ancient environments and climatic shifts. By examining the movements and interactions of these plates, geologists can reconstruct the past, revealing how continents drifted apart or came together, how oceans formed, and how life adapted to changing landscapes. As we explore these fascinating elements of tectonic plates, we may find ourselves captivated by the sheer scale and complexity of the Earth's geological processes. How often do we pause to appreciate the intricate relationships among the plates that form the very foundation of our existence? The delicate balance of forces at play allows us to live on a planet rich in diversity and beauty. In the words of the renowned geologist and author Richard Fortey, "The Earth is a great book, and those who do not read it are doomed to wander." This sentiment encapsulates the importance of understanding the stories told by tectonic plates, for they are the keys to unlocking the mysteries of our planet's past, present, and future. As we continue to immerse ourselves in this world of tectonic plates, let us take a moment to marvel at the beauty and power that lies beneath our feet. The interplay of oceanic and continental plates, along with smaller plates and microplates, creates a dynamic environment that not only shapes our landscapes, but also influences the very essence of life. What wonders will we uncover as we delve further into the realm of tectonic activity? What secrets await us in the depths, waiting to be revealed? The journey of exploration is just beginning, with the Earth inviting us to discover the stories hidden within its layers. Chapter 3. The Mechanisms of Plate Movement. Beneath the solid crust of the Earth, a world of dynamic processes unfolds. At the heart of this intricate system lies the mantle, a layer of hot, semi-solid rock that serves as the engine driving the movement of tectonic plates. Imagine the mantle as a slow-moving river of molten material, where temperatures soar to thousands of degrees, igniting a ceaseless dance of convection currents. These currents arise from the heat generated by the Earth's core, a relentless force that transfers energy outward, creating a cycle of rising and sinking material. Envision this process. Hotter, less dense material from deep within the mantle rises toward the surface, much like a bubble of warm air ascending in a room. As this material reaches the upper mantle, it cools and becomes denser, eventually sinking back down. This cycle, although slow, is persistent, generating a continuous flow that exerts pressure on the overlying tectonic plates. The movement of these plates is not a uniform glide, but rather a series of shifts and jolts, influenced by the relentless push and pull of the mantle below. Gravity plays an equally vital role in this grand orchestration of movements. Imagine standing at the edge of a steep cliff, feeling the pull of the Earth beneath you. This gravitational force acts upon the tectonic plates, encouraging them to move in relation to one another. At divergent boundaries where plates pull apart, gravity assists in the downward movement of the newly formed crust, allowing magma to rise and create new land. Conversely, at convergent boundaries where plates collide, gravity helps to draw one plate beneath another in a process known as subduction. This powerful interaction can lead to spectacular geological phenomena, such as the formation of deep ocean trenches and towering mountain ranges. The interplay of convection currents and gravity does not exist in isolation. It is further fueled by the heat emanating from the Earth's interior. This heat is a remnant of the planet's formation, a legacy of the immense forces that fused together the elements of our world over billions of years. The core, composed mostly of iron and nickel, generates heat through the process of radioactive decay, as well as from the residual warmth of the Earth's formation. This heat not only drives the convection currents within the mantle, but also contributes to volcanic activity and the gradual reshaping of the Earth's surface. Consider the life of Alfred Wegener, a pioneering figure whose ideas about continental drift laid the groundwork for our understanding of plate tectonics. Wegener famously stated, "The continents are not stationary, they are drifting." His insight into the connection between continental movements and the forces beneath them echoes through the ages. It reminds us that the Earth is not a static entity, but a living, breathing organism shaped by the relentless push of heat and the pull of gravity. As we delve into the specifics of these mechanisms, it becomes clear that the Earth is a complex system where multiple forces converge. The heat from the core creates a dynamic mantle, where convection currents rise and fall, while gravity orchestrates the movement of the lithosphere above. Imagine the Earth as a giant engine, where every part works in harmony to create the geological events that define our world. The interaction of these forces can lead to dramatic changes, such as earthquakes and volcanic eruptions. When stress builds at tectonic boundaries due to the movement of plates, it can be released suddenly, resulting in seismic waves that ripple through the Earth. This release of energy can cause the ground to tremble, reshaping landscapes and impacting life in profound ways. The grandeur of tectonic activity is represented in the magnificent features of our planet. The Himalayas, for example, were born from the collision of the Indian plate with the Eurasian plate, a process that continues to this day. This mountain range, standing tall as one of the highest on Earth, serves as a testament to the power of plate movements and the forces that lie beneath. Now let us take a moment to imagine the vastness of the ocean floor. Beneath its depths, mid-ocean ridges rise as testament to the constant creation of new crust, driven by the heat and pressure of the mantle below. These underwater mountain ranges, stretching across the globe, are sites of active tectonic processes where new land is formed at divergent boundaries. As we reflect on the mechanisms driving these movements, it becomes fascinating to consider how the heat of the Earth not only shapes our landscape, but also influences our climate. The geothermal energy that escapes from beneath the surface warms the oceans and atmosphere, playing a vital role in weather patterns and the distribution of ecosystems. Imagining the Earth as a dynamic system reminds us of the interconnectedness of all things. The movements of the tectonic plates are not just geological occurrences. They are part of a larger narrative that encompasses the very essence of life on our planet. As we explore further, it is essential to appreciate how these mechanisms have shaped the history of our planet. The shifting plates have influenced not just the geography, but also the evolution of ecosystems and the development of human civilization. The fertile lands formed by volcanic activity, for instance, have supported agriculture and human settlements for millennia. We can also consider the work of scientists like John Tuzo Wilson, who advanced our understanding of plate tectonics by introducing the concept of transform faults. These boundaries, where plates slide past one another, are sites of great geological activity. His insights remind us that the Earth's surface is a canvas, painted by the movements of these colossal plates over time. Imagining the Earth through the lens of plate movements invites us to appreciate the intricate dance of forces that shape our world. Each rise and fall, each collision and separation, contributes to the ongoing evolution of the planet. It is a reminder that beneath our feet lies a realm of activity that is both powerful and serene, a hidden world of energy and motion. As we continue to explore the mechanisms of plate movement, it is worth contemplating how they influence not only our planet's geology, but also its future. The Earth's ever-changing landscape poses challenges and opportunities for humanity. With each seismic event, we are reminded of our place within this grand tapestry, urging us to respect and understand the natural forces at play. The mantle, with its flowing currents and hidden depths, is a reminder of the intricate workings of our planet. It is a source of life and destruction, a driving force behind the ever-evolving surface that we call home. The mechanisms of plate movement, shaped by heat and gravity, create a dynamic environment where life thrives and transforms, urging us to remain curious about the world beneath our feet. As we immerse ourselves in the mechanisms of plate movement, it becomes essential to appreciate the role of heat in this grand design. The Earth's interior, a vast repository of thermal energy, is not merely a source of warmth, it is the very pulse of the planet. Below the surface, the relentless decay of radioactive isotopes generates immense heat, contributing to the dynamic processes that drive tectonic activity. The heat emanates from the core, gradually radiating outward, where it meets the mantle and ignites the circulation of convection currents. Picture the mantle as an enormous, slow-cooking pot. As the heat rises from the core, it causes the mantle's material to become less dense, allowing it to ascend. This rising material, akin to a pot of water beginning to boil, creates a cycle of movement. As it nears the crust, this material cools, solidifies, and eventually sinks back down to be reheated. This perpetual cycle is a testament to the Earth's ability to recycle its materials, ensuring that the process of plate tectonics remains active and vibrant. The amount of heat within the Earth varies significantly from one region to another, influenced by factors such as the presence of radioactive elements and the thickness of the crust above. Imagine standing in a forest on a cool evening, where certain areas are warmer due to the presence of sunlit glades, while shaded spots remain chilly. Similarly, in the Earth's interior, pockets of heat can lead to localized geological phenomena, including hotspots that may give rise to volcanoes independent of tectonic boundaries. Consider, for instance, the Hawaiian Islands, formed by a volcanic hotspot in the middle of the Pacific Plate. As the plate slowly moves over this fixed source of heat, molten rock surges upward, creating new land. This process illustrates how heat, combined with the movement of tectonic plates, shapes our planet's geography. As we reflect on the interplay between heat and tectonic movements, we can discern how this relationship influences not only the formation of land, but also the incredible diversity of ecosystems across the globe. Areas enriched with volcanic soils often become lush and fertile, supporting a myriad of life forms. The geothermal activity beneath the Earth's surface not only molds landscapes, but also nurtures the intricate web of life that thrives upon them. Gravity, too, plays a pivotal role in this delicate balance of forces. The gravitational pull acting on tectonic plates is a constant reminder of the Earth's massive weight and structure. This force is not merely a passive influence. It actively shapes how plates interact at their boundaries. At divergent boundaries, where plates pull apart, gravity aids in the downward motion of the newly formed crust, allowing fresh magma to rise and solidify into new landforms. At convergent boundaries, gravity's influence becomes even more pronounced. The collision between tectonic plates can lead to one plate being forced beneath another in a process called subduction. This dramatic encounter not only creates deep ocean trenches, but also fuels the volcanic activity that can arise along these boundaries. The Andes mountain range, for example, is the result of the subduction of the Nazca Plate beneath the South American Plate, a powerful testament to the forces at play beneath our feet. As we delve deeper into the world of tectonics, it's fascinating to consider the work of scientists who have sought to understand these complex interactions. The contributions of individuals like Harry Hess, who proposed the theory of seafloor spreading, have illuminated our understanding of how oceanic plates diverge and create new crust. Hess once said, "The ocean basins are the result of tectonic processes." His insights have paved the way for further exploration into how these processes shape our oceans and continents. Imagine the vastness of the ocean floor, where mid-ocean ridges stretch for thousands of kilometers, birthed from the ceaseless creation of new crust. These underwater mountain ranges are not only geological phenomena, they are vital to the Earth's ecological health, providing habitats for countless marine species. The currents generated by the forming crust also play a significant role in ocean circulation, influencing global climate patterns and weather systems. The heat from the Earth's core, combined with the gravitational forces acting upon the tectonic plates, creates a dynamic interplay that is ever-present and far-reaching. This symphony of movement does not exist in isolation. It reverberates through time, shaping the very fabric of our planet and impacting the evolution of life itself. As we consider the implications of these processes, it becomes clear that the history of the Earth is intricately tied to the movements of its plates. Each shift and motion has left an indelible mark on the landscape, influencing everything from the formation of mountain ranges to the development of rich ecosystems. The very act of creation through destruction, where volcanic eruptions can give rise to new land while simultaneously obliterating existing forms, illustrates the dual nature of these geological processes. Every tectonic event tells a story, one that encapsulates the struggles and triumphs of our planet's geological history. The forces at play beneath the crust serve as a reminder of our Earth's age-old journey, one shaped by both the slow and steady movements of plates and the powerful bursts of energy that can reshape the landscape in an instant. As we continue to explore these themes, let us remain mindful of the interconnectedness that defines our world. The mechanisms of plate movement remind us that we are part of a larger narrative, one where the heat from the Earth's core fuels the dynamic processes that shape our environment. Understanding these forces not only enriches our knowledge of geology, but also deepens our appreciation of the delicate balance that sustains life on our planet. In the grand scheme of things, the mechanisms of plate movement are both a chorus of power and a whisper of tranquility. They invite us to ponder the intricate systems that govern our world, urging us to listen closely to the stories written in the rocks beneath our feet. Chapter 4: Plate Boundaries and Their Effects. As we explore the intricate realm of tectonic plate boundaries, we find ourselves gazing upon the incredible forces and dynamic events that shape our planet. Tectonic boundaries are where the edges of these colossal plates meet, each interaction leading to unique geological features and transformative effects on Earth's surface. There are three primary types of plate boundaries: divergent, convergent, and transform. Each type plays a distinct role in the ongoing narrative of Earth's geological story. At divergent boundaries, tectonic plates drift apart, like two friends slowly walking in opposite directions. This separation creates an opening for magma to rise from within the depths of the Earth, where it cools and solidifies to form new crust. Picture the Mid-Atlantic Ridge, a magnificent underwater mountain range formed by this very process. As magma emerges, it not only creates new land but also supports a rich ecosystem. Hydrothermal vents, teeming with unique life forms, thrive in these extreme conditions. Imagine the vibrant communities of tube worms and bacteria that make this environment their home, drawing energy from the chemicals in the water rather than sunlight. This remarkable adaptation showcases the resilience of life, even in the most inhospitable places. Conversely, convergent boundaries present a different narrative, where tectonic plates collide with immense force. When an oceanic plate meets a continental plate, the denser oceanic plate is forced beneath, a process known as subduction. This dramatic encounter gives rise to powerful geological phenomena, including volcanic arcs and deep ocean trenches. The Mariana Trench, the deepest part of the world's oceans, is a direct result of such subduction. Imagine descending into its depths, where darkness reigns and pressure is immense, and yet life persists in forms we are only beginning to understand. When two continental plates collide, the result is often breathtaking mountain ranges. The Himalayas, formed by the collision of the Indian plate and the Eurasian plate, serve as a testament to nature's might. As the land buckles and folds, peaks rise to majestic heights, echoing the power of the Earth's forces. This mountain-building process is a slow but relentless endeavor, ongoing for millions of years. Have you ever stood at the foot of a great mountain and wondered how many eons it took to reach such grandeur? Transform boundaries, on the other hand, are marked by plates sliding past each other horizontally. This lateral movement can create significant stress along the boundary, leading to earthquakes. The San Andreas Fault in California is a prime example of such a boundary, where the Pacific Plate and the North American Plate grind against one another. Imagine standing on a fault line, feeling the earth tremble beneath your feet. The energy released during an earthquake can reshape landscapes in an instant, forming new geological features while reminding us of nature's unpredictable power. The impact of these boundaries extends beyond the physical formation of landscapes. They influence ecosystems and human life alike. For instance, volcanic activity associated with convergent boundaries can enrich soils, creating fertile ground for agriculture. The ash from eruptions, often seen as destructive, can also be a blessing for farmers, rejuvenating the land with essential nutrients. This duality of destruction and creation serves as a poignant reminder of nature's complexity. Furthermore, the oceanic ridges formed at divergent boundaries are not only sites of geological activity, but also essential contributors to ocean circulation. The upwelling of nutrient-rich water from these ridges supports diverse marine ecosystems, benefiting fisheries and global food webs. Have you ever considered how interconnected our planet's systems are? Each element, from the smallest bacteria to the largest mountain range, plays a role in the intricate web of life. As we reflect on these plate boundaries, we can see that they are not merely lines on a map or abstract concepts. They represent the living, breathing Earth, constantly shaping and reshaping itself. The stories told by these boundaries are as varied as the landscapes they produce, from the serene beauty of a gently rolling ridge to the dramatic spectacle of an erupting volcano. Consider the profound insights of Alfred Wegener, who first proposed the idea of continental drift. He once said, "Science knows no country, because knowledge belongs to humanity and is the torch which illuminates the world." His vision paved the way for understanding the movements of tectonic plates and the boundaries that define them. Each discovery in geology serves as a testament to our desire to understand the world we inhabit. As we continue to explore these boundaries and their effects, let us remain mindful of the delicate balance between creation and destruction, chaos and order. The Earth, in its infinite wisdom, offers us a glimpse into its processes through the geological features and ecosystems shaped by these boundaries. What stories do you think lie waiting to be discovered beneath the surface, in the hidden depths of the Earth's crust? The complexities of plate boundaries touch every corner of our planet. From the rolling hills, shaped by ancient forces, to the vibrant ecosystems that thrive in seemingly barren landscapes, the impact of tectonic boundaries is profound. The narratives of divergent, convergent, and transform boundaries intertwine, creating a rich historical tapestry that connects us to the very fabric of the Earth. Imagine standing at the edge of a rift valley, the ground beneath you a testament to the slow, powerful forces at work. The rift, a scar formed by the stretching of the Earth's crust, is a reminder of the active nature of our planet. It is here that we can witness the birth of new land, a manifestation of life's persistent drive to expand and evolve. These boundaries serve not only as geological phenomena, but also as reminders of the past and harbingers of what is to come. The slow but relentless push and pull of tectonic plates will continue to shape our world long after we are gone. Will future generations look back and marvel at the landscapes we now inhabit? The effects of these boundaries ripple across the surface of the Earth, influencing climate, biodiversity, and even human civilization itself. The fertile volcanic soils of regions like the Italian peninsula have supported civilizations for millennia, showcasing how intimately linked our existence is with geological processes. As we move through this chapter of our exploration, we begin to grasp the profound interconnectedness of all things. The Earth is not simply a backdrop for our lives. It is a dynamic system, a living organism that breathes and evolves over time. The boundaries between tectonic plates are not just lines drawn in the sand. They are the very essence of our planet's story, a story written in rock and shaped by time. Consider the vast expanses of ocean where tectonic activity is often hidden from view. The subaqueous landscapes, shaped by divergent boundaries, are home to myriad life forms. Imagine the textures and colors of the coral reefs that thrive in these nutrient-rich waters, a sanctuary nurtured by the geological activity that lies beneath. The beauty of Earth's geological features lies not only in their grandeur, but also in the stories they tell. Each mountain, valley, and ocean trench is a chapter in a larger narrative, woven together by the forces of nature. As we contemplate these relationships, we begin to understand that the Earth is not merely a collection of rocks and minerals. It is a complex, interwoven system that sustains life in all its forms. Reflecting on the words of geologist John McPhee, who once stated, "The landscape is the book of the Earth," we are reminded that every ridge, every valley holds a story waiting to be read. The stories of plate boundaries are woven into the very fabric of our lives, influencing the air we breathe, the water we drink, and the ground we walk upon. As we immerse ourselves in the rich tapestry of geological features formed by plate boundaries, let us embrace the wonder of this planet we call home. The dance of tectonic plates continues, a reminder that beneath our feet, the Earth is alive, forever changing, and forever inspiring. What lies ahead in our exploration of these geological marvels? The journey is far from over, and the stories yet to be uncovered are waiting just beneath the surface. The wonders of plate boundaries extend beyond the geological features we can see. They also play a crucial role in shaping our planet's climate and ecosystems. Consider how volcanic eruptions at convergent boundaries can release vast amounts of ash and gases into the atmosphere. This can lead to short-term cooling effects, as the particulate matter reflects sunlight away from Earth. Imagine how such eruptions might alter weather patterns, influencing rainfall and temperature across great distances. The interconnectedness of these systems reminds us that the Earth operates as a single complex organism, where the actions of one part can reverberate throughout the whole. At divergent boundaries, the formation of new oceanic crust does not merely create land, it also impacts oceanic circulation patterns. The newly formed crust at mid-ocean ridges is often warmer than the surrounding water, causing the water above to rise. This upwelling of warmer water can lead to changes in marine ecosystems, fostering conditions that support diverse biological communities. Picture the vibrant marine life that flourishes in these areas of nutrient-rich waters, an ecosystem sustained by the very geological activity that creates the land beneath the waves. The effects of these boundaries also extend to human civilizations. Many of the world's most populous regions are situated near plate boundaries, where fertile soils and abundant resources draw communities. The Ring of Fire, a horseshoe-shaped zone of active volcanoes and earthquakes encircling the Pacific Ocean, is home to numerous cities and cultures. Here, the interplay between tectonic activity and human life creates a unique relationship, a blend of both awe and trepidation. We often find ourselves living on the edge of nature's incredible power, navigating the delicate balance between harnessing its resources and respecting its formidable strength. Throughout history, many outstanding individuals have sought to understand these powerful geological processes. One such figure, Charles Lyell, once stated, "The present is the key to the past." This philosophy underscores the importance of studying current geological processes to gain insight into the Earth's history. By examining the effects of plate boundaries today, we can piece together the story of how our planet has evolved. Have you ever paused to contemplate how the landscapes we traverse today were shaped by ancient forces, their echoes still resonating through time? As we delve deeper into the influence of plate boundaries, it becomes clear how they contribute to biodiversity. The varied environments created by tectonic activity, mountains, valleys, and coastal areas, serve as habitats for countless species. The rugged terrain of the Himalayas offers microclimates that host unique flora and fauna, often found nowhere else on Earth. In these niches, evolution thrives, driving the diversification of life. Imagine wandering through these ecosystems, attuned to the subtle shifts in climate and habitat that arise from the ongoing geological processes. Moreover, the interplay of tectonic plates induces not only physical changes, but also cultural shifts. Regions affected by seismic activity develop unique architectural styles and disaster preparedness measures, reflecting humanity's resilience in the face of nature's unpredictability. Throughout history, societies have adapted to the whims of the Earth, learning to coexist with its ever-changing landscape. How might our own understanding of the natural world influence the way we design our communities and live our lives? The interaction of tectonic plates is a fascinating narrative, rich with lessons about the interconnectedness of life on Earth. The boundaries they create are not merely geological lines, but rather vibrant intersections where life flourishes amidst the tumultuous forces of nature. Each eruption, earthquake, and uplift of land contributes to the grand story of our planet. As we consider these elements, we find ourselves drawn into a world that is alive with energy, a continuous cycle of destruction and renewal. In this journey through plate boundaries, let us remain mindful of the delicate dance of creation and destruction that defines our planet, the intricate relationships between geological processes and ecosystems. Remind us that every mountain, every valley, and every ocean is a testament to the Earth's enduring legacy. What other stories lie hidden within the rock and soil, waiting for us to uncover their secrets? As we continue our exploration, we are reminded that the Earth is not just a stage for human existence, but a living entity, constantly shaping and reshaping itself in an ever-evolving narrative. Chapter 5. Earthquakes, the shaking Earth. As we shift our focus to the rhythmic and often violent phenomenon of earthquakes, we must first understand the powerful forces that drive them. Earthquakes are the Earth's way of releasing built-up energy caused by the movement of tectonic plates. Picture this: massive slabs of the Earth's crust, sometimes dozens of kilometers thick, are constantly shifting and grinding against one another. This movement is not smooth. It is fraught with tension. As these plates interact at their boundaries, whether they are pushing together, pulling apart, or sliding past one another, stress accumulates over time. Imagine a rubber band being stretched. The more you pull, the more potential energy it holds. Eventually, the tension becomes too great, and the band snaps back into its original shape. Similarly, when the stress in the Earth's crust surpasses its strength, the accumulated energy is released suddenly, resulting in an earthquake. This process is known as elastic rebound. Can you envision the immense energy stored beneath your feet, waiting for the moment when it will be unleashed? This cycle of stress accumulation and release is not random. It follows a pattern known as the earthquake cycle. After a significant earthquake, the crust may settle into a new position, but the stress will begin to build again as tectonic plates continue their relentless movement. This cycle can take years, decades, or even centuries to unfold. The geological record provides evidence of this cycle, revealing that certain regions experience quakes at regular intervals. For instance, the San Andreas Fault in California is notorious for its periodic earthquakes, a reminder of the ongoing struggle between the Pacific and North American plates. As we ponder this cycle, it's intriguing to consider how some of the greatest minds in geology have sought to understand these processes. One such figure, Charles Richter, famously said, "Earthquakes don't kill people, buildings do." His development of the Richter scale in the early 20th century provided a framework for measuring the magnitude of earthquakes, allowing us to quantify the energy released during such events. This insight was revolutionary, bringing clarity to the chaos that earthquakes can create. So how exactly do we measure these immense forces? The science of seismology has developed advanced techniques to observe and record the vibrations caused by earthquakes. Seismographs, the primary instruments used, are designed to detect and record ground motion. Picture a delicate pendulum suspended from a fixed point. When the ground shakes, the pendulum remains still while the base moves beneath it, creating a trace on a rotating drum. The resulting seismogram reveals the characteristics of the earthquake, including its magnitude and duration. Over the years, several scales have emerged to help us understand these seismic events better. The moment magnitude scale, which has largely replaced the Richter scale, measures the total energy released by an earthquake. This scale is logarithmic, meaning that each whole number increase represents a tenfold increase in amplitude and approximately 32 times more energy release. Imagine the difference between a small tremor and a catastrophic quake. The scale allows us to appreciate the magnitude of these events in a tangible way. In addition to magnitude, we also assess the intensity of earthquakes, which reflects the effects of shaking on people, buildings, and the Earth's surface. The modified Mercalli intensity scale offers a descriptive approach, categorizing the observed impacts from not felt to total destruction. It paints a vivid picture of the human experience during an earthquake, reminding us that each event is not just a number, but a profound experience that can alter lives and landscapes. As we delve deeper into the world of seismic activity, we begin to understand how earthquakes can be both a destructive force and a natural component of our planet's geological history. They serve as a reminder of the dynamic nature of Earth, constantly reshaping its surface despite our attempts to establish permanence. The very ground we walk upon has been shaped by countless tremors, each one contributing to the intricate story of our planet. Consider the San Andreas Fault, a striking example of a transformed boundary where the Pacific and North American plates slide past one another. This fault has been the site of numerous significant earthquakes, including the infamous event in 1906 that devastated San Francisco. The destruction was profound, yet it led to advancements in engineering and preparedness that have since saved countless lives. Fascinatingly, some scientists are now exploring whether we can predict earthquakes with greater accuracy. The complexity of the Earth's crust and the myriad factors influencing seismic activity make this a daunting challenge. Yet, researchers are employing cutting-edge technology and data analysis techniques to identify patterns and precursors that may offer clues about impending quakes. Could it be possible that one day we might receive warnings before the ground begins to shake? The quest for understanding continues, weaving together threads of science, technology, and human aspiration. Earthquakes also provide us with opportunities for reflection on our relationship with nature. As we marvel at the strength of the forces at play, we recognize our vulnerability in the face of such power. The Earth may shake beneath our feet, but it also offers a canvas for resilience and innovation. Buildings designed to withstand seismic forces, community preparedness initiatives, and early warning systems are all responses to the challenges posed by earthquakes. As we contemplate the Earth's ceaseless activity, let us remember that these events are part of a larger cycle of renewal and transformation. The land we inhabit is shaped by a continuous interplay of forces, where destruction often gives way to new beginnings. Earthquakes, with all their ferocity, serve as a testament to the Earth's dynamic spirit. Imagine standing upon a mountain that has risen over countless ages, its peaks forged by the collision of tectonic plates. The landscape around you tells a story of upheaval and resilience. Each valley, each ridge, is a reminder of the forces that have sculpted our world. Earthquakes, while often feared, also represent the pulse of the Earth, a reminder that beneath the surface, change is always on the horizon. As we continue to explore the intricacies of our planet, may we find peace in the understanding that the Earth is alive, constantly shifting and reshaping itself. The tremors that rattle our foundations are but a part of this grand narrative, one that has unfolded over millions of years and will continue long into the future. Our journey through the world of earthquakes is but one chapter in the story of our planet, a story that invites us to listen, learn, and adapt as the Earth continues to evolve. As we continue to explore the intricate mechanisms of earthquakes, it is essential to understand the forces at play, not only during an earthquake, but also in the moments leading up to it. The accumulation of stress along fault lines is a gradual process, often taking years to develop. This tension builds as tectonic plates, in their relentless motion, become locked against each other. Imagine a spring being compressed. The longer it is held in that state, the more energy it stores, waiting for the moment of release. This buildup is influenced by various factors, including the type of rocks involved and their physical properties. For example, the strength of the rocks and their ability to deform under pressure can significantly affect how stress accumulates. Some rocks may bend and flex, absorbing energy, while others may fracture more easily. This variability adds complexity to the earthquake cycle, as different regions may experience stress accumulation at different rates. The earthquake cycle can be divided into distinct phases: the initial accumulation of stress, the eventual rupture along a fault, and the post-earthquake phase where the crust settles into a new position. Each phase is marked by its own characteristics and implications for the surrounding environment. After a major earthquake, the crust may undergo a process of adjustment, with aftershocks often following as the ground settles into its new configuration. These aftershocks can be just as alarming, reminding us that the Earth is still in motion even after the primary event has subsided. One can think of the aftermath of an earthquake as akin to a musical crescendo. The main notes have been played, but the echoes linger, reminding us of the power that has just been unleashed. This cycle of stress accumulation and release serves as a crucial element in understanding not just earthquakes themselves, but the broader dynamics of our planet's geology. In the realm of seismology, scientists have developed a variety of tools and techniques to measure these seismic events, enhancing our understanding of their magnitude and impact. Modern seismographs are sophisticated devices that can detect even the faintest vibrations. Picture a network of these instruments scattered across the globe, each acting as a sentinel, capturing the whispers of the Earth. These instruments operate on a principle similar to that of a sensitive microphone, attuned to the subtlest movements of the ground. When an earthquake occurs, the seismograph records the vibrations, producing a seismogram that reveals not only the strength of the quake, but also its duration and the types of waves generated. There are different kinds of seismic waves. P waves or primary waves are the fastest, and can travel through both solids and liquids, while S waves or secondary waves follow more slowly and can only move through solid materials. Imagine these waves rippling through the Earth, each carrying valuable information about the quake's origin and characteristics. The moment magnitude scale is one of the primary tools used to quantify the energy released during an earthquake. This scale provides a more comprehensive understanding of an earthquake's size than its predecessor, the Richter scale. By considering the total energy released and the area affected, this scale allows scientists to assess the impact more accurately. It is fascinating to think about how this numerical representation translates into real-world effects. Each increment on the scale signifies a significant difference in energy release. An earthquake measuring just a few points higher can unleash devastation orders of magnitude greater than a smaller quake. As experts study the aftermath of seismic events, they also employ the modified Mercalli intensity scale to evaluate the human experience of an earthquake. This subjective scale allows for a nuanced understanding of how different regions feel the impact, illustrating that the same earthquake can yield vastly different experiences depending on location, building structures, and local preparedness measures. It is a poignant reminder of the human aspect of these geological phenomena, highlighting that beneath the scientific measurements lies a rich tapestry of human stories. Consider the stories of resilience that emerge in the wake of such events. Communities come together, sharing resources and support, reflecting an innate human capacity to adapt and rebuild. The aftermath of an earthquake often serves as a catalyst for change, prompting advancements in building codes and emergency response systems. The lessons learned from past events shape our future, guiding us towards safer practices and better preparedness. As we contemplate the profound effects of earthquakes, we begin to appreciate their role as both destructive forces and catalysts for growth. They remind us of the Earth's restless spirit and the need for humility in the face of nature's power. The knowledge gained from studying earthquakes not only informs our understanding of the planet, but also fosters a deeper connection to our environment. In this journey through the world of earthquakes, we are reminded that the Earth is a living entity, constantly reshaping itself, and, in doing so, inviting us to be stewards of our planet. As we embrace this knowledge, let us remain vigilant and responsive, understanding that while the Earth may shake beneath us, it is also a source of life, beauty, and resilience. The stories of those who have faced these challenges inspire us, urging us to listen to the Earth's whispers and prepare for the tremors that may come. So, the next time you feel the ground shift, take a moment to remember the incredible forces at work beneath the surface. Each tremor is a reminder of the dynamic planet we inhabit, a force that shapes not only the land but the very essence of our existence. Through understanding, we find peace. And with peace, we can navigate the complexities of our relationship with the Earth. Chapter 6. Volcanic Activity and Plate Interactions. The Earth's crust, while appearing solid and stable, is like a living organism, constantly interacting with the forces present beneath it. Tectonic plates, those immense slabs that create the planet's surface, are at the heart of volcanic activity. Their movements can trigger the fiery eruptions that reshape landscapes and impact ecosystems. Imagine standing on the edge of a calm lake, only to witness a sudden eruption of steam and ash, transforming the peaceful scene into a chaotic display of nature's raw power. Tectonic plates contribute to volcanic eruptions primarily through their interactions at boundaries. At divergent boundaries, where plates drift apart, magma rises from the mantle to fill the gap, forming new crust as it cools. This process occurs most dramatically at mid-ocean ridges, where underwater volcanoes frequently erupt, creating new land beneath the waves. Envision a world where the ocean floor is alive with volcanic activity, where each eruption gradually builds new islands and alters marine ecosystems. Conversely, at convergent boundaries, where plates collide, the dynamics of volcanic eruptions take on a different form. One plate may be forced beneath another in a process known as subduction. This subduction zone creates conditions ripe for explosive volcanic activity. Picture the Pacific Plate sliding beneath the North American Plate, leading to the formation of the Cascade Range in the Pacific Northwest. Here, volcanoes like Mount St. Helens remind us of the Earth's fierce and often unpredictable nature. When it erupted in the early 1980s, it demonstrated the potential for destruction that these interactions can unleash. Each type of volcano is linked to these tectonic processes. Shield volcanoes, with their broad, gently sloping sides, form from the gradual flow of low-viscosity lava, typically found at divergent boundaries or hotspots. Imagine the vast, sweeping landscapes of Mauna Loa in Hawaii, where the lava flows gently and steadily, creating a paradise adorned with rich biodiversity. On the other hand, stratovolcanoes, characterized by their steep, conical shapes, commonly arise from subduction zones, where more viscous lava accumulates. These volcanoes can produce powerful eruptions, with explosive force that sends ash and debris high into the atmosphere. Think of Mount Fuji in Japan, its iconic silhouette standing, as a testament to the complex interactions that shape our planet. But what about those remarkable volcanic features that arise far from plate boundaries? This brings us to the concept of hotspots. A hotspot is an area where plumes of hot mantle material rise, creating volcanic activity independent of tectonic plate boundaries. Imagine a candle flickering in the dark, the flame representing the heat from the mantle, breaking through the crust. The Hawaiian Islands are a prime example of hotspot volcanism. As the Pacific Plate moves over a stationary hotspot, It creates a chain of islands that reveal the process of volcanic formation over millions of years. Each island tells a story of its creation, a narrative woven through the layers of lava that solidified into rock. Hotspots can lead to some of the most fascinating geological features on Earth. The Yellowstone caldera, located in the heart of Wyoming, is another striking example. This supervolcano sits above a hotspot and has produced some of the most powerful eruptions in history. Can you envision the vibrant colors of the hot springs and geysers that dot the landscape, showcasing the heat bubbling beneath the Earth's surface? The Yellowstone area is a reminder of the delicate balance between beauty and danger, where the forces of nature can create breathtaking vistas while harboring the potential for cataclysmic eruptions. The relationship between tectonic plates and volcanic activity is a dance of energy and matter, a symbiotic relationship that shapes our world. Each eruption, each formation, carries with it the legacy of the Earth's history, revealing the story of its formation and the ongoing processes that continue to shape its surface. In the context of plate interactions, we can also consider the concept of volcanic arcs, which form along subduction zones. As an oceanic plate descends into the mantle, it releases water and other volatile substances, lowering the melting point of the overlying mantle. This process results in the formation of magma and, eventually, volcanic arcs. Imagine these arcs as necklaces strung along the edges of continents, where volcanic islands rise above the waves, each one a testament to the Earth's restless spirit. Throughout history, numerous outstanding figures have contributed to our understanding of these processes. One such individual, Alfred Wegener, proposed the theory of continental drift, laying the groundwork for our understanding of plate tectonics. His vision, once met with skepticism, now forms the cornerstone of geological science. As he famously stated, "There is no greater danger than the illusion of knowledge." His pursuit of understanding has paved the way for future generations to explore the intricate connections between tectonic movements and volcanic activity. As we contemplate the forces at play beneath our feet, we can't help but wonder about the future of our planet. How will the movements of tectonic plates continue to shape our world? What new landscapes might emerge from the interplay of fire and earth? The Earth is a canvas, painted by the forces of tectonic plates and volcanic activity. Each eruption, each formation, contributes to the intricate story of our planet. The beauty of a volcanic landscape lies not only in its immediate appearance, but also in the rich geological history it represents. As we stand in awe of these natural wonders, we are reminded of the powerful forces that shape our existence, and the delicate balance of nature that continues to thrive, even in the most volatile environments. The dynamics of volcanic activity and plate interactions serve as a profound reminder of the Earth's ever-evolving nature. As we continue to explore the intricate connections within our planet, let us remain curious, embracing the unknown, and cherishing the wonders that lie beneath the surface. The Earth is alive, and its story is far from finished. The relationship between tectonic plates and volcanic activity unfolds further with the understanding of different types of volcanoes that emerge from various plate interactions. Each volcano tells a unique story, shaped by the geological forces at play and the composition of the materials involved. Consider the shield volcanoes, often associated with hotspots or divergent boundaries. These magnificent structures arise from the gentle, flowing lava that spreads across vast distances, forming broad, shield-like profiles. Imagine standing before the towering expanse of Kilauea in Hawaii, its slopes gently rolling like a giant's back. The lava that emerges here is typically low in viscosity, allowing it to travel far and create extensive landforms. The eruptions of shield volcanoes are usually less explosive, characterized by lava flows that can last for years, gradually building up the landscape. In contrast, stratovolcanoes present a different spectacle. These volcanoes, often found at convergent boundaries, are marked by their steep, conical shapes formed from layers of ash, lava, and volcanic rock. Picture Mount St. Helens, with its iconic peak rising majestically against the skyline. The eruptions from stratovolcanoes can be highly explosive, resulting from the accumulation of viscous lava that traps gases within. When these gases are finally released, the explosive force can propel ash and rock high into the atmosphere, creating a dramatic and often destructive display. The history of these eruptions serves as a reminder of nature's unpredictable temperament. Among the many fascinating aspects of volcanic activity is the phenomenon of volcanic gases. As magma rises toward the surface, it carries with it a mixture of gases, including water vapor, carbon dioxide, sulfur dioxide, and others. Imagine these gases swirling and bubbling within the molten rock, building pressure as they ascend. When an eruption occurs, these gases are released into the atmosphere, sometimes creating spectacular plumes that can travel great distances. One might wonder how these volcanic gases affect our environment. They can contribute to climate change, influence weather patterns, and even provide essential nutrients to surrounding ecosystems. Another captivating aspect of volcanic activity is the role of magma composition in determining eruption style. The mineral content of magma varies widely, influencing its behavior as it rises through the crust. For example, basaltic magma, rich in iron and magnesium, tends to produce gentle eruptions, while andesitic and rhyolitic magmas, which contain higher silica levels, can lead to more explosive events. Reflect on the impact of these differences, how the very composition of the earth beneath our feet can dictate the nature of its eruptions. Hotspots, as mentioned earlier, provide an intriguing counterpoint to the interactions at plate boundaries. They are not confined to the edges of tectonic plates, but instead exist, where plumes of hot mantle material push through the crust. The Hawaiian Islands, formed by the Pacific Plate slowly moving over a stationary hotspot, showcase the beauty of this phenomenon. Each island in the chain represents a chapter in the story of volcanic activity, with the youngest island, Hawaii, still actively shaping its landscape. Imagine the lush greenery, the vibrant colors of the flora, nourished by the rich volcanic soil that results from the ongoing eruptions. Hotspots can also lead to the formation of massive calderas, such as the Yellowstone caldera. This supervolcano, with its vast, sunken expanse, serves as a reminder of the immense power contained within the Earth's crust. Picture the geothermal features that punctuate this landscape: glistening hot springs, bubbling mud pots, and the iconic Old Faithful geyser, which erupts at regular intervals to the delight of onlookers. The vibrant colors of the mineral-rich waters contrast sharply with the surrounding earth, creating a stunning visual display that invites contemplation of the forces at work beneath the surface. As we delve further into the world of volcanic activity, we encounter the concept of volcanic hazards. Understanding these hazards is crucial for both scientists and communities living near active volcanoes. Eruptions can produce pyroclastic flows, ashfall, lava flows, and volcanic gases, each of which poses distinct risks. The 1980 eruption of Mount St. Helens serves as a poignant example of the devastating impacts of volcanic activity. The explosive eruption reshaped the surrounding landscape, decimating forests and altering ecosystems. It serves as a stark reminder of the potent forces at play within our planet, and the need for vigilance and preparedness in the face of these natural events. In the grand scheme of Earth's geological processes, volcanic activity is a critical player in the recycling of materials, shaping the planet's surface and influencing its climate. Eruptions release a wealth of minerals and nutrients back into the environment, stimulating plant growth and fostering biodiversity. Imagine the cycle of life that follows in the wake of an eruption, where new ecosystems emerge from the ashes, drawing life from the very forces that once threatened to destroy them. As we continue to explore the intricate dance of volcanic activity and tectonic plate interactions, we begin to see the broader implications of these geophysical processes on our planet's future. How will our understanding of these phenomena influence our approaches to monitoring and mitigating volcanic hazards? What new technologies may emerge to help us predict eruptions and safeguard communities? The Earth, a living entity, continues to evolve, shaped by the interplay of fire and stone. Each volcanic eruption is a reminder of the forces that lie beneath our feet, a testament to the dynamic processes that have shaped our planet for millennia. As we embrace this understanding, let us remain curious and attentive to the beauty and complexity of the world around us. The story of the Earth is ongoing, and it invites us to witness the wonders that unfold with each passing moment. Chapter 7. The Formation of Mountain Ranges. The Earth's surface is a grand canvas, sculpted by the relentless forces beneath it. As we explore how mountain ranges are formed, let us first return to the intricate dance of tectonic activity. At the heart of this process lies the dynamic interplay of tectonic plates. Picture the Earth's crust not as a single, unyielding shell, but as a mosaic of massive slabs, each in constant motion, colliding, separating, and sliding past one another. It is at these boundaries where the magic of mountain formation begins. When two tectonic plates collide, the results can be nothing short of spectacular. This phenomenon occurs primarily at convergent boundaries, where immense forces are unleashed. Imagine two colossal ships crashing into one another. The energy released is tremendous, creating ripples that spread across the surface. In the case of tectonic plates, as one plate is forced beneath another, a process known as subduction, the Earth's crust buckles and folds, giving rise to majestic mountain ranges. The Himalayas, home to some of the highest peaks on Earth, are a prime example of this process. Formed from the collision of the Indian plate and the Eurasian plate, these towering giants continue to rise, a testament to the planet's ever-changing nature. As you envision the Himalayas, consider the stories they hold. They are not merely mountains, but the result of millions of years of geological artistry. The Indian plate, a massive landmass, surged northward, confronting the immovable Eurasian plate. The collision was not a single event, but a prolonged struggle, a drama that unfolded over eons. The pressure and heat generated by this interaction caused the rock to fold, fracture, and ultimately rise into the sky, creating a breathtaking landscape that inspires awe and reverence. The words of a renowned geologist resonate here. Mountains are the Earth's poetry. Each peak and valley speaks of a history written in the very fabric of the rock. Another stunning example of mountain formation can be found in the Andes, stretching along the western edge of South America. This range has been formed through the relentless subduction of the Nazca Plate beneath the South American plate. Imagine the ocean floor being pushed downward, carrying with it the weight of the ocean and the crust above. As the Nazca Plate descends into the mantle, it melts, releasing magma that fuels volcanic activity. The Andes are not only a mountain range, but also a chain of volcanoes, each contributing to the ever-evolving landscape. Picture the ancient civilizations that have thrived in the shadow of these peaks, drawing inspiration and sustenance from the very mountains that were born from the Earth's tumult. But the formation of mountain ranges is not solely about the dramatic collisions of tectonic plates. Erosion and weathering play crucial roles in shaping these majestic giants over time. As mountains rise, they become the targets of the elements: wind, rain, ice, and temperature fluctuations. Visualize the powerful forces of nature slowly wearing away the rugged surfaces, carving deep valleys and sculpting unique geological formations. Each droplet of rain, each gust of wind, contributes to an ongoing cycle of creation and destruction, a balance that defines our landscapes. Perhaps you can imagine a mountain peak coated in a blanket of snow, slowly melting under the warm sun. As the ice and snow retreat, they reveal the underlying rock, exposing layers that tell a story of millennia. The process of weathering breaks down these rocks into smaller particles, which are then carried away by flowing water or gusting winds. Rivers cut through the mountains, creating canyons and gorges that add to the beauty of the landscape. The Colorado River, for instance, has carved the Grand Canyon over millions of years, a stunning example of the power of erosion at work. In this ever-changing landscape, we find the legacy of great minds who dedicated their lives to understanding the forces that shape our planet. One such figure is John Muir, a naturalist and advocate for wilderness preservation, who once remarked, "The mountains are calling, and I must go." His words reflect not only the beauty of the mountains, but also the deep connection we feel to these natural formations. They are more than mere rocks. They are the stories of our Earth, written in the language of geology. As we consider the impact of erosion and weathering, it is fascinating to think about the role of glaciers. Glaciers, vast rivers of ice that flow slowly down from their origins, have been instrumental in shaping many mountain ranges. Imagine standing at a glacial valley, surrounded by towering peaks, the air crisp and clear. As glaciers advance, they grind against the rock, carving out U-shaped valleys and leaving behind moraines, accumulations of debris that tell the tale of their journey. The Alps, for instance, were profoundly influenced by glacial movements during the last ice age, their current form, a beautiful result of both tectonic activity and the sculpting power of ice. In addition to glaciers, the forces of wind and water contribute significantly to the ongoing transformation of mountains. The relentless wind erodes rock surfaces, carrying away fine particles and reshaping the contours of peaks. Water, in all its forms, acts as both a sculptor and a transporter. Picture a heavy rainstorm cascading down the mountainside, the water channeling through crevices, steadily carving out new paths. Rivers that flow from these mountains are lifelines for the ecosystems that thrive below, carrying nutrients and sediment that support life far beyond the mountains themselves. Through this intricate interplay of tectonic forces and the ceaseless action of erosion, we witness the perpetual cycle of creation and destruction. Each mountain range stands as a monument to both the power of the Earth's interior and the gentle caress of the elements. Mountains rise, erode, and transform, a silent yet ever-present reminder of the dynamic nature of our planet. As we contemplate the formation of mountain ranges, we are invited to appreciate the stunning interplay of forces that has shaped our world. Each ridge and valley tells a story, a narrative woven through time. The grandeur of these formations inspires not only wonder, but also a profound understanding of the Earth's history. Can you feel the weight of the mountains, the slow, deliberate movements of the tectonic plates beneath them? Can you sense the whispers of the wind as it sculpts the landscape? In the heart of these mountains lies a world of complexity, beauty, and resilience. The formation of mountain ranges is a testament to the power of nature, a reminder that even in the slowest of processes, great transformations can occur. As we continue our journey through the geological wonders of our planet, let us remain mindful of the stories that mountains tell, stories of collision and creation, of erosion and renewal, echoing through time and space. As we explore further into the formation of mountain ranges, it becomes apparent that the role of erosion and weathering is nothing short of transformative. After the initial birth of mountains through tectonic forces, these majestic structures face the relentless embrace of time and the elements. Picture a towering peak, its summit catching the first light of dawn, casting a long shadow over the valleys below. Yet, beneath this serene facade lies the reality of constant change, where every gust of wind and drop of rain contributes to a slow yet powerful process. Imagine the mountains as ancient guardians, their surfaces etched with the tales of erosion. Each layer tells a story, revealing the history of the Earth's climate, the flora and fauna that once thrived, and the forces that shaped the landscape. Weathering, The initial phase of this sculpting process involves the breakdown of rocks into smaller particles. This can occur through physical processes, such as freeze-thaw cycles, where water seeps into cracks, freezes, and expands, eventually fracturing the rock. Can you envision the dramatic shifts that take place as these tiny actions accumulate over centuries? Then there is chemical weathering, where minerals within the rocks interact with water and atmospheric gases. Imagine the vibrant colors of oxidized iron, revealing itself through the weathering of rocks in a mountain range. As rocks dissolve and alter, they release essential nutrients back into the soil, nurturing the ecosystems that flourish in the shadows of these giants. This connection between mountains and life is profound, as the very mountains that tower above also sustain diverse habitats. Erosion, in its many forms, plays a vital role in sculpting the mountains into their final forms. Water, perhaps the most powerful sculptor of all, carves landscapes through streams and rivers that meander and twist. Picture a gentle brook tracing its way down a mountain, its waters reflecting the sky as it flows over rocks, smoothing their surfaces over time. This flowing water carries sediments, which can create new landscapes downstream, illustrating the interconnectedness of geologic processes. The mighty Mississippi River, for example, has shaped its own floodplain through centuries of erosion, demonstrating how water can reshape not only mountains but entire regions. Wind, too, holds a crucial place in this dynamic interplay. Imagine standing on a high ridge, where the wind whips around you, carrying tiny particles from one place to another. This seemingly innocuous breeze can wear down rock surfaces, eroding them into fascinating shapes. The striking hoodoos and spires found in places like Bryce Canyon are perfect examples of wind's artistry, where softer rock layers erode faster than harder ones, creating unique geological formations that tell a story of resilience and change. As we consider these forces at work, it is important to acknowledge the influence of climate on erosion and weathering processes. In colder climates, glaciers advance and retreat, reshaping landscapes in dramatic ways. Visualize a glacier, a massive river of ice inching down a valley. As it moves, it scrapes the underlying rock, carrying with it boulders and stones, which are deposited as moraines when the glacier retreats. The rugged beauty of the fjords in Norway, carved by glacial action, offers a breathtaking testament to the power of ice in sculpting the mountains. Not to be overlooked are the effects of human activity on these natural processes. As we pave roads and build settlements, we alter the delicate balance of erosion and weathering. Consider the impact of deforestation, where trees that once held soil in place are removed, leading to increased erosion and landslides. The connection between humanity and nature is complex, and as stewards of the land, we must strive to understand our impact on these ancient giants. In the grand scheme of mountain formation, the interplay of tectonic activity, erosion, and weathering creates a symphony of geological changes. Each mountain range stands as a testament to the Earth's dynamic history, a record of forces that have acted upon it over eons. As we ponder the breathtaking vistas before us, are we not also reminded of our place within this intricate web of life and geology? The mountains invite us to reflect on our relationship with the planet, urging us to preserve their beauty and the ecosystems they support. The stories of the mountains are not merely geological, they weave into the fabric of human history as well. Cultures throughout time have revered mountains, seeing them as sacred spaces, sources of inspiration, and symbols of strength. From the ancient Greeks who viewed Mount Olympus as the home of the gods, to the indigenous peoples who consider the peaks sacred, mountains have shaped human mythology and spirituality. They stand not only as physical landmarks, but also as cultural icons that bridge the past with the present. As we continue to explore the formation and evolution of mountain ranges, we embrace the understanding that these natural wonders are born through a delicate interplay of powerful forces. Each mountain carries with it a multitude of stories etched into its rocks and valleys, waiting to be discovered. Can you hear the whispers of the past in the rustling leaves, or the distant echoes of a time when the earth was still forming? The journey through the creation and shaping of mountains is not just a scientific exploration. It is a reminder of the beauty and complexity of our world, inviting us to experience the wonders that lie before us. Chapter 8. The Ocean Floor in Plate Dynamics. Imagine the ocean floor, a vast and mysterious expanse that conceals the dynamic forces of our planet beneath its shimmering surface. This underwater realm is not merely a flat, featureless plain, but a complex landscape shaped by the movements of tectonic plates. Oceanic tectonic plates are thinner and denser than their continental counterparts, primarily composed of basaltic rock. They serve as the foundation of the oceanic crust, forming the bedrock of our seas and oceans. Picture these plates like enormous, submerged islands drifting slowly on the semi-fluid mantle beneath them. The structure of these oceanic plates is fascinating. They are formed in mid-ocean ridges, where tectonic activity creates new crust as magma rises from the mantle. Envision the Mid-Atlantic Ridge, a colossal underwater mountain range that stretches for thousands of miles, its peaks rising dramatically from the ocean floor. This ridge is a prime example of how tectonic plates are constantly in flux, moving apart at a rate often compared to the growth of fingernails. The process is gradual yet relentless, leading to the formation of new oceanic crust as magma cools and solidifies. As these plates separate, they create unique geological features. Have you ever wondered what lies beneath the waves? The mid-ocean ridge not only generates new crust, but also serves as a habitat for incredible marine life. Hydrothermal vents, found along these ridges, release mineral-rich water that supports vibrant ecosystems. Imagine tube worms, clinging to the rocky surfaces, thriving in an environment devoid of sunlight, drawing energy from the chemicals in the water instead. This remarkable adaptation showcases nature's resilience in the face of extreme conditions. Now let us turn our attention to the significance of ocean trenches, deep, narrow depressions in the ocean floor that serve as vital components of the tectonic puzzle. These trenches are formed at convergent boundaries, where an oceanic plate subducts beneath a continental plate or another oceanic plate. Picture the Mariana Trench, the deepest known point in Earth's oceans, plunging to depths that seem unimaginable. Here, one plate is forced downward into the mantle, creating immense pressure and leading to a series of geological phenomena. The significance of these trenches extends beyond their depth. They are crucial in understanding the tectonic processes that shape our planet. As plates converge, energy is released, often resulting in seismic activity and the formation of volcanic arcs. Imagine standing on the shores of Japan, where the Pacific plate subducts beneath the North American plate, giving rise to stunning volcanic islands like the one that hosts Mount Fuji. The interplay of these tectonic forces is not only a spectacle of nature, but also a reminder of the power and dynamism of our planet. Throughout history, remarkable individuals have contributed to our understanding of plate tectonics. Alfred Wegener, for instance, proposed the theory of continental drift, laying the groundwork for the modern understanding of plate dynamics. His insights opened the door to exploring how the ocean floor is shaped and reshaped over time. Imagine his determination as he gathered evidence from various fields, paleontology, geology, and climatology, to support his theory. "Science knows no country," he once said, emphasizing the universal quest for knowledge. As we delve into the intricacies of oceanic tectonic plates, we can appreciate the balance of creation and destruction inherent in their movements. The ocean floor is continuously being renewed, a cycle of birth and rebirth that echoes the very essence of our planet. The formation of new crust at mid-ocean ridges stands in stark contrast to the destruction occurring at ocean trenches, where old crust is consumed back into the mantle. This dynamic interplay raises intriguing questions. How does this balance affect the ecosystems that thrive in these environments? What secrets lie hidden in the depths of the trenches, waiting to be unearthed. Imagine the ocean floor as a living archive of Earth's history, where each layer of sediment tells a story of ancient climates, life forms, and geological events. The study of oceanic tectonic plates provides insights not only into the mechanics of the Earth, but also into the broader narrative of life itself. It invites us to ponder the interconnectedness of all things, from the smallest microorganisms thriving in hydrothermal vents to the majestic mountains formed by the collision of plates. As we explore the depths of the ocean floor, we uncover not only the physical features shaped by tectonic processes, but also the profound impact these forces have on our planet's climate and biodiversity. The ocean plays a crucial role in regulating temperatures, absorbing carbon dioxide, and supporting a myriad of life forms. The movements of tectonic plates influence these processes, creating diverse habitats that foster unique ecosystems. Consider the significance of ocean trenches in this context. These deep-sea regions are not merely geological features, they are hotspots of biodiversity. Life flourishes in the darkness, where pressure is immense and light is a distant memory. Imagine the strange and beautiful creatures that inhabit these trenches, each adapted to survive in an environment that seems inhospitable. From the peculiar anglerfish with its bioluminescent lure to giant squids, the depths are teeming with life forms that defy our understanding. The interplay of forces at work beneath the ocean is both beautiful and awe-inspiring. The ocean floor is a testament to the Earth's history, shaped by the relentless movement of tectonic plates. As we continue to investigate this hidden world, we find ourselves captivated by the mysteries it holds. The more we learn, the more we realize how interconnected these processes are with our own existence. Imagine standing on the shore, gazing out at the vast sea, and recognizing that beneath the surface lies a world of dynamic change. The ocean floor is not a static entity. It is a living, breathing part of our planet's ecosystem. With each movement of the tectonic plates, new features emerge, while others are consumed, reminding us of the transient nature of our world. As we explore the ocean floor and the dynamics of plate tectonics, we uncover the stories of resilience and adaptation that define life in these depths. The ocean, with its vastness and mystery, invites our curiosity and compels us to seek understanding. It is a reminder that beneath the tranquil waves, a vibrant world exists, shaped by the very forces that create our mountains and valleys. With each exploration into this hidden realm, we deepen our appreciation for the intricate connections between geological processes and the life they sustain. The ocean floor, a cradle of life and a canvas of geological history, continues to inspire wonder and inquiry. What other secrets does this expansive world hold? What new discoveries await those willing to venture into the depths? As we journey through this chapter, let us keep our minds open to the wonders of the ocean floor and the dynamic processes that govern it. The interplay of tectonic plates serves as a reminder of the Earth's ever-changing nature, an eternal cycle of creation and destruction that shapes our planet and sustains life within it. The ocean's depths are a treasure trove of geological marvels, with each trench and ridge telling a story of Earth's ceaseless evolution. These features are not merely passive recipients of tectonic activity. They actively influence the environment around them. Imagine the profound impact of ocean trenches on ocean currents and ecosystems. As tectonic plates shift and fold, they create barriers that redirect the flow of water, influencing climate patterns and the distribution of marine species. Ocean trenches, such as the Mariana Trench, serve as gateways to understanding the forces at play deep within the Earth. These deep-sea environments are not just the lowest points on our planet. They are dynamic systems that can shift the balance of marine life. The unique physical and chemical conditions found in these trenches contribute to the development of specialized ecosystems that thrive in high-pressure, low-light environments. Can you envision the strange forms of life that exist in such extreme conditions, adaptations, honed over millions of years? Among the extraordinary organisms that inhabit these depths are extremophiles, microorganisms that flourish under conditions once thought to be inhospitable. These tiny life forms not only defy our understanding of life's potential, but also offer insights into the possibilities of life beyond Earth. They demonstrate resilience, thriving in the darkness of the trenches, feeding on chemicals released by hydrothermal vents. Imagine the excitement of scientists like Dr. Sylvia Earle, who has dedicated her life to exploring these oceanic depths. She once said, "The sea is the most important place on Earth," highlighting the critical role of ocean ecosystems in maintaining the health of our planet. As we consider the role of ocean trenches in the greater tectonic narrative, we must also observe their contribution to the carbon cycle. The subduction of oceanic plates, which brings carbon-rich sediments deep into the Earth's mantle, plays a crucial role in regulating atmospheric carbon levels. Imagine this process as a vast recycling system, where ancient carbon is returned to the depths, influencing global temperatures and climate over geological timescales. The interaction between oceanic plates and continental plates at subduction zones provides a powerful illustration of Earth's interconnected systems. When these plates converge, they create significant geological activity, including earthquakes and volcanic eruptions. The pressure that builds along these boundaries can lead to sudden, dramatic events that reshape landscapes and alter ecosystems. Picture Mount St. Helens. Its eruption, a stark reminder of the power hidden beneath the surface. Each eruption is a testament to the forces that lie beneath our feet, forces that connect the depths of the ocean to the peaks of mountains. The study of oceanic trenches and mid-ocean ridges continues to unveil the mysteries of our planet's past and present. Researchers employ advanced technology, such as submersibles and remotely operated vehicles, to explore these hidden worlds. With each expedition, we gather more knowledge, piecing together the history written in the rocks and sediments of the ocean floor. Imagine the thrill of discovering a new species, or a unique geological feature that was previously unknown, adding a new chapter to our understanding of Earth's processes. The significance of mid-ocean ridges should not be understated. They are not only sites of crustal formation, but also centers of biological activity. The ecosystems surrounding these ridges are teeming with life, nourished by the minerals released from hydrothermal vents. Imagine the vibrant colors and unusual shapes of the creatures that inhabit these unique environments, each adapted to thrive in the extreme conditions found near the vents. The discovery of these rich ecosystems has raised questions about the origins of life and the potential for life on other celestial bodies, such as Jupiter's moon Europa, which is believed to have a subsurface ocean. As we contemplate the ocean floor and the dynamics of tectonic plates, it is essential to recognize the delicate balance that exists. The processes of creation and destruction are interwoven, maintaining the planet's geological stability. Each earthquake, each volcanic eruption, is a reminder of the power of the forces at play beneath the crust. The ocean floor is a living testament to this ongoing cycle, a place where life and geology intersect in remarkable ways. As we continue to explore and learn about the oceanic depths, we are reminded of our connection to this vast and mysterious world. The ocean floor, with its mid-ocean ridges and deep trenches, shapes not only our planet's landscape, but also the life that flourishes within it. The more we uncover, the more we understand the importance of preserving these ecosystems, for they hold keys to understanding our planet's past and safeguarding its future. What other wonders lie beneath the waves, waiting to be discovered? What stories do the sediments hold, whispering secrets of ancient climates and ecosystems? The ocean floor invites us into a realm of exploration and discovery, a journey that promises to reveal the intricate connections between geology, biology, and the very essence of life itself. Each dive into these depths brings us closer to understanding the profound mysteries of our Earth, reminding us of the beauty and complexity of the world beneath the waves. Chapter 9. Human Impact on Tectonic Activity. Human activities have long been intertwined with the natural forces that shape our planet. As we delve into the phenomenon of tectonic activity, it becomes increasingly clear that our actions can influence the very processes that govern the movements of tectonic plates. Imagine standing atop a mountain, gazing out over a landscape sculpted by the slow but relentless forces of nature. Yet, beneath this serene surface, human undertakings can stir the earth in unexpected ways. One of the most striking ways in which human activities can induce tectonic phenomena is through the extraction of resources. Mining, a practice as old as civilization itself, can have profound effects on the stability of the earth. Picture the vast networks of tunnels and shafts carved deep into the crust, where miners seek precious metals and minerals. As these subterranean spaces are created, and, in many cases, left behind, the weight of the overlying rock can lead to structural failures. This phenomenon is known as induced seismicity, where the removal of material from the Earth's crust alters the stress distribution, causing the ground above to shift. Consider the case of a large mining operation in a region known for its seismic activity. The extraction of resources results in the destabilization of geological formations. Over time, the accumulated stress may lead to minor tremors or, in some cases, significant earthquakes. Imagine the unsettling realization that the very pursuit of minerals could trigger the ground to shake beneath our feet. What once felt like a stable foundation can suddenly transform into a source of unpredictability. Another significant contributor to induced seismicity is the creation of reservoirs. When water is impounded behind a dam, the pressure exerted by the immense weight of the water can impact the geological structures below. Envision a vast body of water, calm and reflective, yet holding within its depths the potential to alter the earth itself. In areas where fault lines exist, the added stress from a reservoir can prompt the movement of tectonic plates. This is not mere speculation. There are documented instances where the filling of a reservoir has been linked to increased seismic activity. For instance, in the 1960s, the construction of the Kariba Dam on the Zambezi River led to the formation of a large reservoir. As the water levels rose, the region experienced a series of earthquakes, some with magnitudes strong enough to be felt far from the source. The relationship between human-engineered structures and natural geological processes highlights the fragile balance our planet maintains. Have you ever considered how the manipulation of water and land can reverberate through the layers of the Earth? In earthquake-prone areas, the role of engineering becomes crucial. Scientists and engineers work tirelessly to create buildings and infrastructure designed to withstand the forces of nature. Imagine a city nestled against a mountain range, where the risk of earthquakes is ever present. The structures that rise in such areas must be resilient. Advanced engineering techniques incorporate materials and designs that absorb shock, allowing buildings to sway gracefully rather than crumble under pressure. Take, for example, the work of engineers in Japan, a nation renowned for its seismic activity. They have pioneered innovative technologies that allow skyscrapers to move with the tremors of an earthquake, reducing the risk of catastrophic failure. Imagine walking through a city where the buildings sway gently, almost like trees in a breeze, responding to the Earth's movements rather than resisting them. This approach not only protects lives, but also preserves the cultural and architectural heritage of a region. Yet while we strive to engineer resilience, the very act of construction can also bring unforeseen consequences. The excavation required for foundations, the alteration of natural water flow, and the compression of soil can all contribute to changes in the local geological landscape. This interplay between human ingenuity and the natural world is a delicate one. What if the measures taken to protect us inadvertently create new challenges? As we reflect on the interactions between human activities and tectonic phenomena, it is essential to acknowledge the outstanding individuals who have devoted their lives to understanding these complex relationships. Geologists, seismologists, and engineers work hand in hand, seeking answers to questions that have long puzzled mankind. Their research not only deepens our understanding of the Earth, but also informs the decisions we make as a society in regard to land use, resource extraction, and urban planning. Consider the words of a prominent geologist who once noted that understanding the risks we face is the first step toward mitigating them. This perspective drives the ongoing quest for knowledge in a world where human impact is increasingly felt. Each discovery and each new insight adds to the mosaic of our understanding, guiding us as we navigate the challenges posed by the Earth beneath us. The intricate web of human influence on tectonic activity invites us to think critically about our role in shaping the planet. Can we strike a balance between our needs and the preservation of the natural world? As we continue to explore this relationship, it becomes evident that our actions carry weight. Each decision we make, from resource extraction to urban development, has the potential to ripple through the layers of the Earth, influencing not only our immediate surroundings, but also the grand geological narrative of our planet. Imagine a future where our understanding of tectonic activity informs our every action, where we design cities that harmonize with the rhythms of the Earth, rather than resist them. As we ponder this possibility, let us remain mindful of the interconnectedness of our world. The Earth is not merely a backdrop for human activity. It is an active participant in our story. Each tremor, each eruption, each shift in the ground reminds us of the power that lies beneath our feet, urging us to tread thoughtfully upon this vibrant planet. The journey we undertake as stewards of the Earth is not just about survival. It is about thriving in harmony with the natural forces that shape our existence. Through our collective efforts, we can forge a path that respects the delicate balance of tectonic forces while ensuring a safe and sustainable future for generations to come. As we ponder the complexities of our relationship with the Earth, we find ourselves at a crossroads where science and humanity intersect, shaping the world we inhabit. The impact of human activities on tectonic phenomena extends beyond mining and reservoir creation. It also encompasses the engineering practices employed in urban planning and construction. In regions where seismic risk is elevated, the meticulous design of infrastructure is paramount. Imagine a cityscape meticulously crafted to withstand the tremors of the Earth, where every building is a testament to the harmony between human ingenuity and geological realities. The engineering discipline has evolved significantly over the years, especially in regions prone to earthquakes. Enhanced building codes are now established to ensure that structures can endure not only the forces of gravity, but also the dynamic forces unleashed during seismic events. These codes are informed by extensive research and the accumulated knowledge of past earthquakes. Can you envision how each design choice, from the materials used to the shape of the buildings, works in concert with the natural forces at play? In Japan, engineers have developed a system that incorporates base isolators, which allow a building to move independently of ground motion. Picture a towering skyscraper, anchored firmly to the ground yet able to sway gently, absorbing the shocks of an earthquake. This innovative technology is a direct response to the lessons learned from catastrophic events, such as the Great East Japan earthquake. After such tragedies, the engineering community has made it their mission to bolster resilience, ensuring that future generations can inhabit these structures with a sense of safety. Yet, despite these advancements, there remains an inherent vulnerability tied to human activity. The very act of constructing large buildings or extensive infrastructure can inadvertently change the stress distribution of the Earth's crust. Think of a massive construction project. The excavation for foundations, the alteration of natural drainage patterns, or the weight of towering structures all influence the geological stability of a region. Each of these actions can have far-reaching consequences, subtly shifting the equilibrium of the surrounding environment. Consider the role of urban development in areas near fault lines. As cities expand and populations grow, the demand for housing and infrastructure increases. This growth often leads to the repurposing of land, the diversion of rivers, and the alteration of natural landscapes. Imagine the delicate balance that exists in these regions, where the pursuit of progress must be weighed against the potential for geological disturbance. Have we truly accounted for the long-term implications of our development choices? Moreover, the relationship between human activity and tectonic processes can also be observed in the context of geothermal energy extraction. As we seek sustainable energy sources, the tapping into geothermal reservoirs presents a dual-edged sword. While harnessing the Earth's heat can provide clean energy, it also carries the risk of inducing seismic events. The extraction of steam or hot water from beneath the Earth's crust alters pressure conditions, creating an environment where minor earthquakes can occur. Picture a geothermal plant nestled in a serene landscape, where the promise of clean energy coexists with the potential for unforeseen geological activity. The stories of those who have pioneered in this field are equally compelling. Engineers and geologists have come together to study the delicate balance between energy extraction and seismic risk. Their collaborative efforts aim to develop guidelines that minimize the impact of geothermal projects on local geology. Each conversation and research paper contributes to a broader understanding of the interconnectedness of human activities and the Earth's dynamic systems. In the realm of induced seismicity, the concept of feedback loops emerges. As we alter the Earth's surface, whether through mining, construction, or energy extraction, we may inadvertently create conditions that lead to earthquakes. Imagine a cycle where human intervention leads to geological reactions, which in turn prompt further human responses. Have we considered how this cycle could shape our future? The ripple effects of our activities extend beyond immediate geological concerns. They also encompass societal implications. Earthquakes can disrupt communities, displace populations, and inflict economic damage. Understanding the relationship between human actions and tectonic phenomena is crucial not only for scientific inquiry, but also for creating resilient societies. The choices we make today will echo through generations, influencing how communities prepare for and respond to seismic events. As we explore the human impact on tectonic activity, we are reminded of the importance of interdisciplinary collaboration. Geologists, seismologists, urban planners, and engineers must work hand in hand to forge a path forward. Imagine a world where scientific understanding informs policy decisions, ensuring that our cities are designed with both human needs and geological realities in mind. In this ongoing journey, the quest for knowledge continues to guide us. Each discovery, each technological advancement, and each reflection on our past informs our approach to the future. The intricate dance between human activity and tectonic processes invites us to ponder our responsibilities as stewards of the Earth. How can we enhance our understanding while fostering a sustainable coexistence with the planet's geological forces? As we stand at this intersection of science and society, it is essential to foster a culture of awareness and preparedness. By recognizing the ways in which our actions influence the Earth, we can strive to mitigate risks while embracing innovation. The Earth, in all its complexity, remains a constant reminder of our place in the larger narrative of existence. Each rumble beneath our feet serves as a gentle nudge, urging us to tread thoughtfully as we shape the world around us. In contemplating our impact, we are drawn not only to the challenges, but also to the opportunities that lie ahead. The potential for resilience, adaptation, and harmony with the natural world is within reach. As we continue to explore the multifaceted relationship between human activities and tectonic phenomena, we are reminded that the journey is as vital as the destination, shaping our understanding of the planet we call home. Chapter 10. The Future of Plate Tectonics Research. As we gaze into the horizon of tectonic plate research, we find ourselves on the cusp of a new era, one illuminated by remarkable advancements in technology and scientific understanding. The tools available to geologists and seismologists today have evolved dramatically, enabling them to peer into the Earth's crust with an unprecedented clarity. Imagine a world where satellite technology, with its ability to capture minute movements of the Earth's surface, helps us track tectonic shifts in real time. The precision of these tools has not only enhanced the accuracy of plate movement measurements, but has also opened doors to more detailed modeling of geological phenomena. Today, researchers employ a technique known as INSAR, or interferometric synthetic aperture radar, which utilizes satellite imagery to monitor ground deformation. Picture this: scientists capturing the subtle shifts in the ground caused by tectonic stress, providing invaluable data that can predict potential earthquakes months in advance. The ability to visualize changes in the landscape, as though viewing the Earth through a magnifying glass, allows scientists to analyze patterns that were previously hidden in the noise of geological data. With these insights, they can create more sophisticated models to simulate tectonic behavior, ultimately leading to a deeper understanding of how these colossal plates interact. Furthermore, advancements in seismic monitoring networks have transformed our ability to detect and analyze earthquakes. Dense arrays of seismometers now blanket regions prone to seismic activity, capturing an intricate web of data that reveals the Earth's inner workings. Visualize a vast network of sensors, each one acting like a sentinel, listening to the subtle vibrations of the Earth. This data provides critical information on the frequency, location, and intensity of seismic events, empowering scientists to assess risk more accurately and develop strategies to mitigate the impact of potential disasters. Understanding plate movements is not merely an academic pursuit, it has profound implications for disaster preparedness. As we reflect on the catastrophic events of the past, such as the devastating earthquakes that have struck densely populated areas, it becomes evident that knowledge is our greatest ally. Think about the significance of predicting tectonic activity. With the ability to anticipate earthquakes, communities can take proactive measures to safeguard lives and infrastructure. Early warning systems, fueled by the data gathered from modern technology, can provide precious seconds or even minutes of alert time, allowing people to seek safety before the ground begins to shake. Consider how cities like Tokyo have implemented rigorous building codes and disaster response plans in the wake of their seismic history. These measures, informed by scientific research, exemplify the potential of understanding tectonic movements to save lives. As Professor Shimizu, a renowned seismologist, once said, "Preparedness is not just a reaction to disasters. It is a commitment to understanding the forces that shape our world." This commitment is essential in fostering resilience in communities vulnerable to tectonic events. As we look toward the future, predictions for tectonic activity become increasingly sophisticated. Scientists are harnessing the power of machine learning to analyze vast data sets, revealing patterns that may have eluded human analysts. Imagine complex algorithms sifting through years of seismic data, identifying trends and anomalies that may indicate impending tectonic shifts. The potential for these technologies to enhance predictive capabilities is vast, offering hope for improved disaster readiness in the face of an uncertain future. Moreover, the implications of ongoing tectonic activity extend beyond immediate geological concerns. Our planet, a living and breathing entity, is influenced by the movements of its plates in ways that transcend regional boundaries. The interconnectedness of tectonic plates means that changes in one part of the world can ripple across the globe. For instance, the shifting of the Pacific plate can impact volcanic activity in the Ring of Fire, a region teeming with seismic energy. Visualize the delicate balance of this system, where a tremor in one area may cause a cascade of responses in others, reminding us of the intricate web of connections that bind our Earth. As we embrace these advancements, we must also acknowledge the importance of interdisciplinary collaboration. The future of plate tectonics research lies not solely within the realm of geology, but encompasses a myriad of fields, from computer science to urban planning. By fostering a collaborative spirit among scientists, engineers, and policymakers, we can cultivate a more comprehensive approach to understanding and mitigating the risks associated with tectonic movements. Imagine the possibilities that emerge when diverse minds come together, pooling their expertise to create innovative solutions for a safer tomorrow. In addition to technological advancements, there remains an urgent need for public education and engagement. As we uncover the mysteries of tectonic activity, it is imperative to share this knowledge with communities at risk. Picture workshops held in schools and community centers, where residents learn about the science of earthquakes and the measures they can take to protect themselves and their families. When people are equipped with knowledge, they become empowered, transforming fear into preparedness. As we ponder the future of plate tectonics research, we cannot overlook the implications of climate change on tectonic activity. The interplay between melting glaciers, rising sea levels, and shifting tectonic plates is an area ripe for exploration. Visualize the potential for increased seismic activity in regions previously thought stable, as the weight of ice recedes and the Earth responds to these changes. This intersection of climate science and geology invites a new dialogue, prompting researchers to consider how our changing planet may influence tectonic dynamics. Unquestionably, the journey ahead is filled with challenges and uncertainties. However, the spirit of inquiry and discovery that has propelled the field of plate tectonics will continue to guide researchers as they seek answers to complex questions. As we venture into this future, we are reminded of the words of a great scientific mind. The important thing is not to stop questioning. Each question leads us closer to understanding the forces that shape our world, inviting us to continue exploring the depths of our planet with wonder and curiosity. The significance of these advancements is not lost on us. With every new discovery, we inch closer to a world where we can live in harmony with the planet's dynamic nature. The quest for knowledge in tectonic plate research is not merely an academic endeavor. It is a mission to protect lives and preserve communities from the unpredictability of the Earth beneath our feet. As we ponder the future, let us remain steadfast in our commitment to understanding the rhythms of our planet, ensuring that we are prepared for whatever may come our way. As we embrace this journey toward a deeper understanding of plate tectonics, it is essential to acknowledge the role of public policy in shaping our response to tectonic activity. The collaboration between scientists and policymakers is vital for translating complex geological data into actionable strategies that enhance community resilience. Imagine a world where scientific insights guide urban development, ensuring that buildings and infrastructure are designed with the unpredictable nature of tectonic movements in mind. This proactive approach requires not only the expertise of geologists, but also the input of engineers, urban planners, and community leaders. Such interdisciplinary collaboration fosters innovative designs that can withstand seismic forces. Picture a city designed with flexible structures that can sway with the Earth's movements rather than resist them, much like the graceful sway of a tree in the wind. This vision can become a reality through thoughtful planning and a commitment to utilizing our growing knowledge of plate tectonics. Another critical aspect of the future of tectonic research lies in the realm of global cooperation. Tectonic activity knows no borders. Earthquakes and volcanic eruptions can have far-reaching effects that cross national boundaries. As we consider the interconnected nature of our planet, the importance of sharing data and insights becomes clear. Imagine a global network of scientists working together, pooling resources and knowledge to monitor tectonic activity across regions. This collaborative effort could lead to more accurate predictions and early warning systems that benefit not just a single community, but entire nations. The international scientific community is increasingly recognizing the need for such collaboration. Initiatives like the Global Earthquake Model are already in place, allowing researchers to share seismic data and improve risk assessments on a global scale. This interconnectedness represents a promising avenue for the future, where knowledge transcends geographical confines and fosters a unified approach to understanding and responding to tectonic phenomena. Moreover, as we look ahead, we must also consider the impact of emerging technologies on our understanding of plate tectonics. Artificial intelligence and machine learning are revolutionizing the way we process vast amounts of geological data. Imagine algorithms that can analyze seismic patterns with an accuracy that far exceeds human capabilities, identifying subtle changes in tectonic activity that may indicate impending shifts. Such advancements have the potential to enhance our predictive models significantly, giving communities more time to prepare and respond. These technologies can also aid in simulating potential earthquake scenarios, allowing researchers to assess the effectiveness of different building designs and disaster response strategies. Picture a virtual landscape where scientists can visualize the effects of various tectonic movements on urban settings, testing the resilience of structures in a controlled environment. This proactive strategy will enable better preparedness and response, ultimately saving lives and minimizing damage. Yet, with these advancements comes the responsibility to ensure that the knowledge gained is accessible and understandable. Public engagement is crucial in demystifying the science behind tectonic activity. Picture community workshops where scientists share their findings with residents, fostering an environment where people feel informed and empowered. This dialogue can help dispel fears and replace them with knowledge, enabling individuals to take personal responsibility for their safety in the face of tectonic uncertainties. The significance of education in shaping a culture of preparedness cannot be overstated. Imagine children learning about the science of tectonics in schools, growing up with an understanding of the forces that shape their world. This foundational knowledge can influence how future generations approach urban planning, disaster response, and community resilience. By instilling a sense of awareness and responsibility from an early age, we can cultivate a society that is better equipped to face the challenges posed by tectonic movements. As we contemplate the implications of our changing climate, it is essential to recognize the interrelationship between tectonic activity and environmental shifts. The ongoing effects of climate change are anticipated to influence tectonic movements in ways that warrant further investigation. Imagine coastal regions grappling with the consequences of rising sea levels, where the weight of retreating glaciers alters stress distributions in the Earth's crust. Such changes could lead to increased seismic activity in areas previously deemed stable, highlighting the need for continuous research that bridges the fields of geology and climate science. In this dynamic landscape of knowledge and discovery, we are reminded of the importance of remaining open to new ideas and perspectives. The future of plate tectonics research is a testament to the power of curiosity and inquiry. Each question we ask propels us closer to understanding the profound complexities of our planet. As we forge ahead, let us embrace the spirit of exploration, driven by the desire to unveil the mysteries of tectonic movements and their far-reaching implications. The horizon of plate tectonics research is filled with promise, beckoning us to explore the depths of our planet with renewed vigor and enthusiasm. Each advancement, each collaborative effort, and each moment of public engagement draws us closer to a world where we can coexist harmoniously with the dynamic forces that shape our environment. As we move forward, let us carry with us the knowledge that our journey, rooted in science and driven by a commitment to understanding, holds the key to a safer and more resilient future.